Here's again a pretty simple question in which there are three blocks A, B, B, C and C, D, each of whose lengths are given. This is 0.1 meters, this is 0.2 meters and this one is 0.15 meters. The respective Young modulus is given and the area of cross section is given, and this is the 10 kg mass hanging over here. G can be taken to be 10 meters per second square. We need to find out the distances by which B, C, D are shifted down. So this is a simple question. The first thing which should strike your mind is that you should apply the formula Y is equal to stress upon strain. By finding out the strain, we'll find out how much is the extension in this particular block, and by that we can find out how much distances are B, C and D shifted downwards. Now let us first consider the block AB. For finding out the strain, we first need to find out the stress in this block AB. So for finding out the stress, we always cut it from middle. Let us cut it here. This is AB cut from between. This was A, this was B, and this was a 10 kg mass here. So on this whole system, the net vertical force is 10 G. So to balance that, the tension acting here would be equal to 10 into G. Therefore, on the upper surface, by Newton's third law, the tension or the pulling force will be equal to 10 into G. This force is constant throughout the cross section area of this block AB. Therefore, we can write the stress directly equal to T upon A, since the same force is acting throughout the cross section area of the block AB. Otherwise, we would have needed to integrate. Therefore, this becomes equal to 10 into G upon the area of cross section is 10 raised to minus 7. Now we need to find out the change in length of this block. We can write Y is equal to stress upon strain upon delta L upon L, with delta L is the change in configuration, L is the original length of this block. Therefore, delta L comes out to be stress into L upon Y. So on putting the values, we get delta L1, that is the change in length of the first block. This comes out to be 10 into 10 upon 10 raised to minus 7 into L, the original length of the block AB, that was 0.1 meters, 0.1 upon the Young's modulus of the material of the block AB, that is 2.5 into 10 raised to 10. This comes out to be 10 raised to 3 on this side, which gets cancelled from above to give a 10 here. This comes out to be 0.1 upon 25 meters, that is equal to 4 into 10 raised to minus 3 meters. So we know the extension of the first block. Therefore, the distance by which this point B shifts down is equal to 4 into 10 raised to minus 3 meters. So we get the answer for the first part as 4 into 10 raised to minus 3 meters. Now, for the second block BC, the same tension exists in BC, which can be found out by cutting it, that is equal to 10 G. Therefore, the stress is equal to 10 into 10 upon area of cross section, that is 10 raised to minus 7. Again, we need to find out the change in configuration. Delta L2 can be written as stress into L upon Y, that is 10 raised to 2 upon 10 raised to minus 7 into the length BC, that is equal to 0.2 upon the Young's modulus, that is 4 into 10 raised to 10, which comes out to be 5 into 10 raised to minus 3 meters. Now, the change in length of this block BC is 5 into 10 raised to minus 3 meters, but the distance by which this point C will move down will be equal to 5 into 10 raised to minus 3 meters plus the distance by which this point B has moved down, that is equal to 4 into 10 raised to minus 3 meters. Therefore, the distance by which blocks this point C, or rather the intersection surfaces between this block and this block shifts down, is equal to 5 plus 4 is equal to 9 into 10 raised to minus 3 meters. Now again solving similarly, For the third block, we get stress to be equal to 10 raised to 2 upon 10 raised to minus 7, and we get the change in length of the block CD to be equal to 10 raised to 2 upon 10 raised to minus 7 into the length, original length of this block, that was equal to 0.15 upon the Young's modulus, that is equal to 10 raised to the power 10, which comes out to be 15 into 10 raised to minus 3 meters. Now, the distance by which point D will move down will be equal to the change in length of this block plus the distance by which block C has moved down, that is equal to 9 into 10 raised to minus 3 meters. Therefore, the answer for the third part comes equal to 15 plus 9, that is equal to 24 into 10 raised to minus 3 meters. So, final answer is that point B, or rather this level, moves down by 4 into 10 raised to minus 3 meters. This level moves down by 9 into 10 raised to minus 3 meters, and this level moves down by 24 into 10 raised to minus 3 meters. This is our final answer for this question.